Hey, what's up, guys? Chung here again. So this time let's take a look at this LeetCode problem, number 1568, minimum number of days to disconnect island. This is another problem during this week's weekly contest. So, okay, you're given like a 2D grid consisting of either 1 or 0. Okay, 1 means it's a land and 0 means it's water. And an island is it's four directionally connected. Okay, a group of ones. Mm, so the grid is said to be connected if we have exactly one island. Otherwise, it's said disconnected. So the tricky part for this problem is that in one day, we are allowed to change any single land cell from 1 to 0, and you need to return the minimum number of days to disconnect the grid. Okay, so let's take a look at a few examples here. So in case of this grid here, so these four ones consists of a single island, right? And in order to make them disconnected, we can either remove these two nodes. Basically, we remove this one from 1 to 0. After that, those two ones are not connected, like in four directionally connected, right? So that's the first example. And the second example is this one. So if you have a 1 and a 1, okay? And so in order to make those disconnected, you need to remove both of them because a single one is also like treated as a connected island, okay? That's why we need to remove both this one, this two ones to 0. That's why we have 2 here. And okay, now for this example, the example 4 here, you only need to remove one once, which is this one. Okay, so you just need to remove this one to make this this one island disconnected. Okay, and okay, here's the tricky part. Okay, if you have two ones here, and you need the output is 2. Okay, so of course you'll be thinking of, okay, so we just need to remove this one and this one so that this island will become disconnected. Okay, and the example stops at here. Okay, and then you will of course thinking of this way, right? Let's say if we have another one here. Okay, in order to make this one like disconnected, it seems like we have to remove three ones. Okay, to make this island disconnected. So in this case, the answer will be 3 here. But the tricky part of this problem is that it, the problem itself, it didn't give you the example in this case. So I think this example 4 and 5 is kind of misleading. Okay, and the reality is you need at most 2 days to make any island connected. So why is that? Let's say we have 3 ones here. The the reality is that we don't have to remove any of those. All we need to remove is this one and this one, right? If you remove these two ones, of course this big island is still connected, but there's like an isolated one here, so which will make this island disconnected. That's the tricky part. Basically, you just need to realize that you need at most 2 days to make any island disconnected. Okay. As long as you can realize that one, then the problem becomes much simpler. Okay. Okay, so let's just follow that idea here, right? So since we have already know that, we just need to remove at most 2 days. Okay. So what we need to do is we're gonna create a helper functions like the called the island count. Okay, so the island count will simply return the number of islands in the current grid. Okay, and so our logic would be simply uh, we just called it its island count first. If its island count is greater than one, okay, then we can simply return zero. Just for example, this one, okay, 1010. So in this case, 1010. Okay, so those there are already two disconnected islands in this graph. That's why as long as the at the initial state the island count is greater than one, we simply return zero. Okay. Now the part is that we just need to check if by removing any one of by changing any one of the ones to zero, if we can make this island count greater than one. If that's the case, then we know the answer is one. If none of those two conditions are met, then we know the answer is two. Okay. And to check the one answer here, we simply loop through all the grids here. Whenever we met a one there, we just flip that one to zero, and then we call this island count to check the island count to give us the count of the island. And then after that, we just set this one set this zero back to one. Yeah, that's basically the idea here. Okay, so first let's define like a helper function called island count. Okay, so the way we're counting an island, we just use like a BFS search or DFS search, doesn't really matter. We just start from any ones, okay, and then we do a BFS or DFS search, and then we just finish looping all the ones, okay, and then every time when we have like see a one there, we just increase the island count by one, okay, and in the end we just return the counts, okay. Basically the answer is zero, okay, and then uh, we're gonna need like a visited, okay, visited set, okay. Hmm. So for I in range, okay, yeah, let me define a few variables here, like the length, the row and the column here. And then the n is the length of the grid 0. Okay. So for I in range m and for j in range n, okay. If the grid I and j is equal to 1, okay, then we first increase the answer by 1, okay, and then we create a queue, okay. Since we're going to use the BFS search, queue is going to be a collections of DQ, okay, DQ and I and j, okay, and then visited dot add, right, I j, okay, and then after the rest is just a standard BFS search template, while q, then we have current I, current j equals q dot pop left, okay, and then we also need the directions here, 4 directions, like always. Directions equals to up, uh, down, uh, left, and right. Okay. So here for direction, for D in directions, okay, new I equals to current I plus D0, and new J equals to current J plus D1, okay. Then we do a simple boundary check. and new j is between 0 and n. Okay, and new I and new j not in visited. Okay, and grade. Okay, new I and new j is 1. Okay, then we add that. We simply add that cell. Okay, into the queue here. New j. Okay, of course, don't forget to add this one to the visited set here. Mhm. Okay, in the end, we simply return the answer, okay, which is the island count. Okay, now we can implement our main logic here. Basically, if the island count is greater than 1, without doing anything, we simply return 0, right? That's the first case. Second one is we're trying to check if the 1 is the answer. How do we check the 1? We just do another for loop here, right? Range m. Basically, we try flip each one, okay? If any of it uh, will make the island count greater than 1, then we know the answer is 1, okay? If the grade I and j equal to 1, okay, then we simply do a grade I, j equal to 0, and then we do a check. If island count, okay, is greater than 1, then we return 1, okay? And after that, we just need to set the grade back to 1, okay? Okay, and if 1 is not the answer, we can simply return 2 here, right? Yeah, I think that's pretty much it is. Let's try to run this code here. No. Uh, hmm. Uh, why 0? Uh, uh, let me check this. Let me do a quick check here. So I just want to see what's the answer here. 4. Oh, it seems like my island count method is not giving me the correct answer because I'm expecting 1 in this case. Let's see. Oh, I see. Here, since I'm not setting this grade ij to 0, so every time we have a 1 here, the answer will be increased by 1. So, yeah. So instead of increase the answer at the beginning, we should increase the answer at the end. Okay. That should give us the oh, this one here. Yeah, that should give us the correct answer. Let's try to run this one more time. Sorry. My bad. This thing actually doesn't really matter. So we just need to add one more conditions here. And I, j, not in visited. Okay, that's all we need to check here. Okay, because if there's already one that had already been visited before, we don't want to count it as part of the island. We don't want to treat it as a new island. Okay, so yeah. Yeah, so this time it works. Okay, I think we can just remove this print here. Yeah, so submit. Cool. So it passed. All right. That's all it matters. How about space and and space complexity? So basically, the space complexity will be, this island count will be n square, right? Because we'll be visiting each of the nodes, each of the cell once. Okay, uh, and we have like another layer of the loop here, which is that's also n square. So n square, so it's gonna be time is gonna be the n to the power of 4. Okay, yeah. And the space, how about space? Space is set here. Yeah, space is n square because at each of the island count we're storing all the cells in the visited. So the square is gonna be the space is gonna be n square. Okay. Yeah, I think that's just to recap. This problem is it's very tricky. I think that's why a lot of people downvote this problem is because this example is really misleading. If you follow this one and you were thinking about, okay, the worst case scenario, I have to remove all the ones in this grid, which will be unsolvable, essentially unsolvable. You just need to realize this. Just maybe try to focus on this example one here. So basically, as long as you have 4 ones stick together, right? Then you can just remove any ones in the diagonal ones, and then you can make this islands disconnected. So which means the maximum days needed is 2. With that in mind, I think it shouldn't be that hard to come up with this kind of like solution. Okay. Okay, cool guys. I think that's pretty much I want to talk about for this problem. Yeah, thank you so much for watching the videos, guys, and stay tuned. I'll be seeing you guys soon. Bye bye.